Welcome to the Microscopists, a bite-sized bio podcast, hosted by Peter O'Toole, sponsored by Zeiss Microscopy. Today on the Microscopists.
I have pretty long arms. I barely could be, so if you were looking down the binocular, I could barely adjust the field diaphragm because it's actually on the back of that huge tower. So it wasn't, how should we say, easy to use, but it was the best microscope that I've laid my hands on for many, many years.
Welcome to the Microscopists. Today, I chat with Jason Swedlow from the University of Dundee, whose open source tools are revolutionising microscopy. While I've known Jason personally for many years, this is a great opportunity to find out more about Jason on a personal level, from everything from his decisions to stop competitive road cycling through to his travels around the world. Catch Jason at home and hear about what motivates him. You'll discover some great tips and tricks for getting to the top, as well as hear about his first microscope experiences, which are quite entertaining to hear about. Hi, I'm Peter O'Toole, and today in the Microscopist, I'm actually meeting up with Jason Swedlow from the Wellcome Trust Biocentre at the University of Dundee. Jason, hiya.
Hi, Pete. Good to see you.
Yeah, likewise. Seems to be seeing a lot of you these days with different initiatives going on.
It does. Lots of meetings, lots of Zooms. It's enjoyable.
Yeah, a lot. Yes, a lot. And here's another one. Huh?
Yes, exactly.
Jason, I'm going to kick on it. You are a travelling man, very much known, certainly on the circuit. You're always, very seldom have I ever met you when you've come from Dundee. Usually you've come from somewhere completely different en route back to Dundee via somewhere else as well. So actually this lockdown must be terrible. You're stuck at home. How's your family coping?
Well, first of all, I love it. I absolutely love being home. This has been fabulous. I've been locked down for, I think it's 11 or 12 weeks now. So I absolutely love meeting people on these trips. I love the talking and the ideas and the exchange. I hate the airports. I detest the hotels. The planes, I'm okay with because it's usually quiet and I can work. And there's, I'm not in, 17 meetings and all of that stuff. So I actually don't mind the flights because I can get work done. But I have this thing with my kids, just, texting back and forth, where are you, Dad? Who knows, in yet another anonymous orange hotel room. So, traveling is part of the job, but also I think it's part of a way of connecting with the community. And so that's why.
Yeah, I think talking to other people as well, Zoom is great. It's been very productive, very efficient time-wise.
Yeah.
But it's kind of using the existing networks. I'm really not sure that you don't necessarily develop close new networks. You don't have that same interaction. I don't know what your thoughts are around that.
There is an element of that, and it is something actually I've thought about, which is you often get invited to meetings from people who know you, which is great. And it's always great to see those people and interact and reinforce those connections. An awful lot of great collaborations and exchanges of ideas come out of that. But yes, there's a certain, I don't want to say redundancy, a bit of repetitiveness. I'm sure you find the same thing. You do see an awful lot of the same people giving talks over and over again. My father was an academic, and he was, his view was you never gave the same talk twice. And that's, if you think about that, what that means, it's actually it's a pretty high bar to set for yourself. I have to say I have given the same talk twice, but definitely, seeing the same things over and over again. Sometimes it's good to reinforce things, to hear things a few times, that helps. But on the other hand, yeah, there's it would be nice. What I really enjoy is going to meetings in communities I know nothing about. Right? So I'm walking in, I'm literally struggling to keep up with the vocabulary just to understand the words that people are using. That ends up being quite fresh. It's challenging, but it's also an awful lot of fun.
No, I totally agree. And you do get invited to give the same talk, as in we get invited to give the same talk. And it's the same material time and time again, but a slightly different audience.
Yeah.
Well, actually, each talk is spun slightly differently.
Yes.
But thank goodness they're a different audience. Otherwise, I'd run out of jokes. At least I can keep repeating.
I think I've heard all your jokes, Pete.
Oh, you haven't seen what I've got lined up for you yet.
Okay.
I think let's make it kind of refreshing that you can have different audiences, and I think technology moves on that enables, it opens to different markets. Microscopy is great for moving from market to market. The high-plex imaging, the spatial profiling has just opened up a whole new area for microscopists to be talking to and impacting that we weren't previously, on our agenda.
Yeah. It's an unbelievably powerful and flexible technology, and it just keeps extending its scope. And my version of what you just said, which is very similar, which the whole single cell profiling explosion, and that's for a lot of people the adoption of imaging, truly imaging in that world is just starting. Right? But there's a massive, it is becoming, and it will be transformational.
No, I know we've talked a bit about this in the past, but actually I'm going to skip on. I'm not going to look at the past. Just think about the now. IDR, timeliness for this and the explosion of data. This is surely, this is how it's not one innovation, is it? It's innovations in parallel that come together that really enable things. Yes. Yeah. So tell us a bit about IDR and where you see that fitting into it all. Oh, Jason, you just cut out there for a second for me. Sorry. I bet you wish you could do that to me all the time. Just just annex me. Jason, tell me a bit about IDR.
Okay. So IDR, image data resource, built upon, informed and built, at least initially, with the ideas that are coming out of the genomics and the structural biology community, that data sets that are associated with peer-reviewed publications are valuable. They're valuable for integrity, they're invaluable for reuse, they're invaluable for just reinforcing the concepts that are being presented in a publication. And so in a very naive way, can we do the same thing for bioimaging data? The problem is, and so if you put it that way, it's easy to say, oh yes, we should. And so
yeah,
that's fine. But, right, as you well know, Pete, but the plethora of different modalities, the data sizes, the annotations, there's a huge amount of complexity in all of this. And so IDR started the project in 2015. It was built upon some ideas that we worked on through Glencoe, the company I run with, the JCB Data Viewer, that was built with Rockefeller University Press. Then we, thinking about, rather than doing a journal-specific resource, now doing effectively a community resource. And so we're fortunate enough to get some funding from BBSRC to support that work. And in collaboration with the European Bioinformatics Institute, BBI, we started building that. And around, I think, mid-2016 or so, IDR is then in production, taking data sets from the community, working through the annotations, and et cetera, and then publishing them online. And it's just taken off from there. And so, the ramp up, I think initially it was, people thought, well, will this work? And we still have a long way to go before this is publishing imaging data is routine and is happening for the majority of studies that use imaging. But definitely making progress there. I think pretty important step was 2018, I guess, publishing a paper with our colleagues at EMBL and EBI, trying to lay out ideas around about archiving data, annotating data, making targeted databases, so-called added value databases, and trying to think about linking all of those together, and to imagine what a mature image data, the word we use there is ecosystem, or a community of data of data resources would look like. So, yeah.
One of the biggest challenges is surely going to be getting the user community to know about it. It's easy to get the likes of cores to know about it, microscopy geeks to know about it, but actually we're not the ones generating tons of relevant data. It's the users, and to get them engaged and to buy into it,
Right.
It's surely going to be a huge challenge.
Right. So, I mean, there's a slightly trivial answer and there's a serious answer. The trivial answer is, yeah, that's why I'm on the road. And that's why, as we were talking about before.
So he's just a salesman.
Yeah. Well, part of science is, communicating your ideas. But more seriously, Pete, actually what's happening now and where adoption is coming from has less to do with us directly and more to do with journal editors. And so Nature Springer journals have recommending, have on their website, IDR as a recommended repository for these data, which is great. But something else is happening where specific editors in journals are targeting papers. So a paper that has a significant amount of imaging data is sent to us. And literally several times a week now, we get an email that reads more or less word for word, "Dear IDR, I have a paper about to be accepted in fill in the blank name of the journal. The editor has told me I must deposit the data in IDR. Please help." And then, we go from there.
So I guess, looking at your analogy being a salesman, I can see your lovely bifold doors behind you. I can imagine the salesman coming in and you're saying that's one way, that's what you're doing. And yet you've also got the building regulators coming around telling you have to buy double glazing.
I mean, we...
And Jason, before we get, that is sunshine, isn't it? Are you actually really in Dundee?
This is Scotland, okay? And yes, I am in Dundee. Welcome to my house.
It is sunny. It is sunny.
Yeah. And I will tell you one lovely thing about living all the way up here on the east coast of Scotland is, I listen every morning to the weather forecast on the radio, and it's atrocious down in England. And there'll be storms coming in, and even on the west coast of Scotland. But here on the east coast, it's great. So.
Okay. I've got some quick fire questions for you, Jason.
Go for it.
See how this goes. So you just got to answer one or the other. No hesitation.
Okay.
So don't think about it.
I'm ready.
Tidy or messy?
Oh, definitely messy.
Tea or coffee?
Always coffee and large amounts.
Book or TV?
It has to be one or the other?
Yeah.
Depends when, time of day.
Eat in or eat out?
Both.
Okay. UK or US?
UK.
Oh, there goes your American passport.
I wish it were that easy. I've lived in Europe for 20, I think it's coming up to 22 years now. And it's been great. I love living here.
Yeah, so back in 98, I think it was, when you joined and set up and started to develop. So let's look back at that, because you came to the UK, Wellcome Trust Biocentre, up at the University of Dundee, and developed that into what it is today. And it's very well known internationally for its imaging, which is very much driven by yourself through that, adopting new technologies. But you're not a biologist from your first degree, are you?
No,
I love that look of confusion of when I say you're not a biologist.
I'm not a biologist.
I'm a biologist.
Where is this going? No,
So your degree, what was your degree?
Bachelor's degree chemistry. 5 years racing bicycles. And
So you had 5 years. So from your degree, you then spent 5 years racing bicycles before going back into science?
Yeah.
Oh, wow. So how serious was your cycling?
Pretty. Finished university, was really enjoying racing. My dad was an academic, my mom was a nurse. We weren't exactly sure what to do with someone who was devoting themselves to going down hills very fast and things like that. And actually, I've subsequently had some discussions with my mother. She was pretty worried. Initially in Boston and then in San Francisco, I was racing. Had a job in San Francisco at UCSF, working in a laboratory, and I was learning a lot about pretty kind of hardcore biochemistry, protein purification. And UCSF at the time was this amazing place. There was just so much going on. It still is, still an amazing research environment. And I got the bug. And admittedly, going fast down hills is pretty great. But you start thinking about the longevity, and at some point, start seeing, well, okay, this is fun, but there's eventually, a neuron fires and says, okay, time to be serious. And so
you must be semi-pro.
No, all amateur. And so the problem with that, Pete, in at least at that time in the bicycling world, the transition from amateur to, I was on a team, we had some sponsorships, etc., but it was pretty lean. So you have to work to, for your food and your tires, basically. And I, to make the transition to being a full pro is a big step. And I was racing against guys, so I was getting up at 5 a.m, doing 40 or 50 miles, getting home, going to work, coming back in the evening, going out for another 30, 40, sometimes much longer, just to get the miles on the legs. But in fact, we had pros staying with us in our apartment, and they were doing more miles, but they were getting up at 9 o'clock and going out and coming home, having lunch, have a nap, going out again, and that's the difference. I mean, it's just impossible to compete with someone who's able to do that.
So you say you got the bug when you were at UCSF. Is that the first? I guess as a chemist, you were never really using light microscopes.
No.
I'd be guessing. Obviously, a lot of your career has been based around the use and application and data of microscopy. So when was the first time you used a microscope?
My first rotation in graduate school. It was a complete accident. So I'll try to make this as concise as possible. 1986, 1987, the first examples of what was called site-directed mutagenesis were published. And so, you could look at the sequence of a protein, mutate an amino acid, and then look at what happened, and then assay that effect. And so this was being done on enzymes, but the technology to make a point mutation in a cDNA had just been developed, and the protein expression was in the very early days. And Dave Agard's group at UCSF was, if not the first, then definitely one of the first to make a mutation that just didn't just kill the enzyme. So, but in fact, they had switched the specificity of a bacterial protease from small hydrophobics amino acids, and just by changing the binding site, they had broadened the specificity of the enzyme. So rational design. And it was mind-blowing that, you could do such a thing. And so that's what I was going to do. That was my career goal. And I wanted to join Dave's lab, and I was interviewing with him, I should say. We talked an awful lot about the various projects. And at the end of about an hour discussion one evening, he said, I have this other side of my lab. Do you want to hear about that? And so I thought it would be rude to say no. So I said, sure. And he said, we do a lot of three-dimensional structures of cells using microscopy. And I thought, I had no idea what he was talking about. But after a few discussions, it seemed like so UCSF at that time was one of the few graduate programs that was doing rotations. So you would spend a year as a graduate student, your first year, sampling different laboratories. At that time, it was a very novel idea. So I just thought, well, hey, I'll do a rotation in this just to learn about it, just because it sounds cool. And short version is, that was it. It was over. I was a microscopist. So.
Yeah. Congratulations. Welcome to the club.
Yeah, exactly.
I think a lot of us were very late to the club, or relatively late to the club. So just thinking a bit more about the microscopes themselves. Tell us about this one.
Well, that's a Zeiss axiomat. And there's a few people in the world who have seen those. So that was a design that came out of Zeiss in the 80s to celebrate the retirement of one of their senior engineers. At least the way I heard the story, I haven't verified this with anybody in Zeiss, but this was effectively their retirement gift. Design your microscope. And you can sort of see in the image behind you, it has various modules. But you can also see that you can't see the whole thing in that image. So this is an inverted microscope. The objective lens and turret are way at the top. I have pretty long arms. I barely could be, so if you were looking down the binocular, I could barely adjust the field diaphragm because it's actually on the back of that huge tower. So it wasn't, how should we say, easy to use, but it was the best microscope that I've laid my hands on for many, many years. It was the darkest microscope, so no stray light, and so fluorescence, just the images were incredibly crisp. And in my PhD lab, so Dave Agar and John Sadat were one of two labs, and I think they were leading the way to get a CCD camera and put it on a microscope. And that they had a Zeiss, John had a Zeiss axiomat, and they got a CCD camera from Tektronix. And they put it on that microscope. And it was one of the first digital microscopes in the world. That was my PhD.
Wow. That's cool. I've got to say, it's got one of the longest focus stalks that I've seen on a microscope as well. And that is huge.
Yeah.
It's like a magic wand.
Yeah, exactly. Well, it has to be, right? Because actually, you are, you need a way, your arms are kind of reaching around all this. It wasn't ergonomically designed. Right? That wasn't its point.
And in its own microscope lab or in the open bench?
No, in a positive pressure room, filtered air, tachymat, the whole thing.
So filtered air, which sounds quite good, because I could have sworn you've told me something in the past about microscope rooms maybe not being the best place in the world.
Yeah, so, okay, here's the story. So you imagine this is positive pressure, all filtered, tachymats on the outside, special room for this microscope, and there's various computers in the room as well, controlling the CCD, and the other revolutionary thing about this microscope, again, you have to remember when this is the late 80s. Yasushi Hiroka in John's lab had managed to get a stepper motor onto the objective turret. So now you had a three-dimensional optical sectioning microscope. So the stuff that we now take for granted, no one would even think twice about the novelty of that. This was extraordinary. So amazing lenses, all of that stuff, at that time to collect a three-dimensional set of optical sections through a DAPI stained nucleus was an amazing feat and took an awful lot of time on the computer, et cetera. So you would sit there collecting these data sets, and I was sitting in the microscope room collecting some data, and John Sadat, my other PhD advisor, opened the door and he said, everything going okay? I said, yeah. And I said, he kind of sniffed the room and he said, did you fart? And I said, no, I definitely didn't fart. And he said, are you sure? And I said, John, believe me, if I farted, we would know it. He said, okay, we don't fart in the microscope room. The fart gases condense on the lenses. And that is a true story. And but it also, I would just say, it speaks to the exacting standards that John had for his microscopy, and the way that. So, just to talk, it would be hours to talk about how everything was integrated on that microscope.
I'd love to know the science behind that.
Yeah, exactly.
How the gases collect.
Sorry for the long story, Pete.
Just switching tack a bit. So you came to Dundee in '98. How did you find the transition? That's quite a big move to go from one country to another country. Yeah. How was that? How did you find that? Were you nervous about switching countries? Confident? What were the problems that actually brought about in itself?
Probably the short version, Pete, is that you're in a place where people are nominally speaking the same language, so they use the same words, but everything is different. And so you really have no idea what's going on around you. And so, the decision to leave the U.S. was complex, had job offers in the U.S., job offers, and the offer for Dundee here in the U.K., and it seemed like a bit of an adventure. But arriving in a place where people say things to you and you're conscious that you have no idea what someone is saying, and you don't even know what questions to ask, trying to clarify. That was the challenge, right? And that's true in social settings. True, trying to find schools for your kids. It's and it's true in the scientific environment as well. So. It's hard to move. I think, but most scientists have felt that. Right?
And you'd recommend a big switch, different nationalities?
Yes.
Yeah. Well, I guess so, being as you chose UK over US.
Well, but it's right. It was right for myself. It was right for my family. So yeah, it's worked out. That's my view. That's a very personal view, right?
So, just thinking. So that's one challenge. You've got quite a big career. You've had lots of diversity to it. When have you found the most challenging time? That's a big sigh.
Yeah, challenging. There's lots of different types of challenges, and so I guess, I could ask back. Okay, well, what kind of challenge do you mean, Pete? But I think probably the hardest time is really that transition. And this was my experience. I think it's true for an awful lot of academics. It's that transition where you're going from, junior independent investigator into a tenured position or whatever that is. There's different names for it in different worlds. It's a really tough time. It is really, really tough. And it's tough on your head. It's quite demanding, just, what you have to deliver. I would say that was one of the toughest times.
And that's mostly, I presume, down to pressure then, and self-pressure, a lot of it.
Yeah. When I came to Dundee, like I said, my dad was an academic, and I'd seen an awful lot of the rough and tumble of academia. And I have to say, a lot of things I see happening around me and happening to my colleagues. I remember my father talking about in the 60s, right? Over dinner, the things that would happen. So So I'm not, in no way do I mean to say that, to diminish the challenges of being an academic. It's hard, but it definitely is something. It's just, there's a lot of it seems to be intrinsic to the system that we've built. But yeah, I don't know. Sorry.
I think that's a tough time. I think you'll have a lot of people listening or watching that agree with that and are possibly feeling that now as well.
Yeah. I mean, I will say that, I'm now officially old, right? And so I can say these things, but it took me decades to learn that how tough it is related directly to a commitment to being, world-class and excellent. And being world-class and excellent is really hard, right? And when I came to Dundee, because I was an academic, I said, okay, I said to myself, I have to schedule a meeting with the department chair, that time a guy by the name of Pete Downs. And I need to talk with him about the requirements for tenure and get this all clear. And I scheduled that appointment, and I said, I was very polite, thank you for meeting me. I'd like to know how you plan on evaluating me for tenure, so I can properly organize my my targets and all of the things around focus and organization and planning. And Pete said, international reputation. And I said, and I didn't say this, but I thought, axe murderer. and
you'd have a lot of citations at that point.
Yeah, exactly. And I said, well, okay. And we had this discussion, but it took me a while to understand what Pete was saying. Was part of this was a Dundee thing. Dundee had a desire to put itself on the map, to be a world-class research institution. And what that meant was that when, for example, Pete or any of the other senior staff would go to meetings, they wanted to hear people talking about you, frankly. I mean, why would people be talking about you? Okay, well, maybe axe murder, but more seriously, world-class science, right? Yeah. And so I think that's what makes it so hard, is that the aspiration is to be absolutely world-class.
Yeah, making significant contributions.
Yeah, and we now all live in a global community and a global scientific enterprise, and so by definition, what we do when you use the word significant or significance, it has to be on that scale. That's incredibly challenging, and it's really, really super hard. It puts all of us at a very high bar.
So this is interesting, because you can do it. You can make a significant impact, but you can't just make one significant impact. You ride a wave, and eventually that wave will come to the end, and you then have to look for the next wave, and you have to keep looking to make those significant impacts. And actually, so you started off as a chemistry as a degree. You went into your biophysics. You moved into far more cell biology, and now actually a lot of your work is data analysis through the microscopy era. And so actually you've been surfing all sorts of different oceans, not even just different waves. So yeah, it seems to me as though actually opportunistic is the wrong term to use, but you see where there's an opportunity and where your strengths are, and you followed them, and you've not been scared to change tack.
Yeah, I wish that all sounds great, Pete. I wish I could say that there's any kind of foresight or even thought about, am I changing a tack? I think in all cases it's, wow, this is an interesting problem, and this problem I'm facing is stopping me from making progress, and so I guess I have to think about it and address it. And that's about I'll confess, that's the depth of analysis or kind of reflection before embarking on any of these things.
But you've never left it to say, well, there's a problem. I need someone to solve it so I can carry on my research. You've seen a problem and shifted to solve the problem. You've taken it upon yourself to move it.
Well, at least the problems I've chosen to engage with, yes,
Yeah.
absolutely.
Yeah.
I mean, not all. You can't solve all problems, right? And so I think there is a bit of, is this so? This was a big discussion. I remember in graduate school at UCSF. Is this an important problem, right? And we would have these discussions about, is this an important question? And is this a fundamental question that is important to solve? And I think one of the things that was around UCSF, and definitely in Dave and John's lab, is marrying a scientific problem with the technological capabilities to solve that problem, and understanding that the two go hand in hand. And sometimes you don't need new technologies, but sometimes you do. And when you do, you can't pretend that you don't, because you do. So sorry, it's kind of trite, but that's true.
Yep.
And the other one is to figure out how to okay, what is the technological steps that you need to deliver?
So you say about following, I mentioned following opportunity. You said it's been kind of just, I've had to take that opportunity, but actually you've got your own spin-out company as well. So following the open microscopy environment and moving that forward. So tell us a bit more about that, because that's not trivial either, setting up a start of a successful spin-out now.
Well, yeah, I mean, so OME started as an open source project, and we had made some progress. So OME started 2000, 2002. The first grants were from the Wellcome Trust here in the UK, late 2002. And we started making some progress, and by about 2005, we had some commercial companies coming to us and saying, well, this is all great, but there's these open source licenses. We need a commercial version. And so Glencoe Software was founded explicitly with the goal of having another way to deliver the technology, to expand the audience or expand the user base or to expand the adoption, because we had pharmaceutical companies and technology companies saying, we want to engage with this, but we, especially at that time, it's changed an awful lot over the last several years. But, 2005, 2006, I guess these discussions we were having discussions a year or so before that, no pharmaceutical company would allow an open source library inside their operation. Or at least they would say they wouldn't. Sometimes they didn't know they were actually using open source libraries, but anyway. And I actually, in the very early days, we were talking to some of the microscope manufacturers. We're talking to some of the old, you might remember Metamorph.
Yeah, of course.
So we visited their offices in eastern Pennsylvania, and their president, Jeff Stuckey, we were in this meeting. He said, well, this is all fine, but we absolutely cannot use open source software. We will not allow open source software through our door. And his CTO was sitting there, and he said, well, actually, we use open source software to run all our mail servers. And he looked at me and said, we do? I said, yeah, absolutely. It's the best stuff out there. And so part of it was education, but part of it was also providing a choice for a broader community to access this technology. Yeah.
So that's been successful. Your research has obviously been fantastically successful. How do you balance spinning out a company and your academic research? Great face.
Balance is not something that it's not a word that I would really bring to the table on this one, Pete. It's how do you survive is probably more. The best answer to that is, look, I told you why, there's reasons that we do these things. I work with an amazing group of people. My colleagues are absolutely world-class. And they're just the best. And that's probably the best way is not, probably the best question is not how do you balance anything like this, because everything is it's an awful lot of work. But I have an amazing group of colleagues that I work with. The team that I work with is and have now worked with for some cases approaching 15, 18 years, are just incredibly dedicated, incredibly capable, expert, and passionate. Boy, oh boy, do we argue. We get in each other's faces. We'll go to the mat, we will argue quite vociferously because and that's the passion.
Do you always win those?
That's the best answer I have.
Yeah. Do you always win those discussions?
Never. Never. No, that's not true. I think one of the things I most enjoy about OME and Glencoe both is that no one in the organization is right all the time, or is the singular voice or view, right? I can't participate in those projects without my colleagues, and they can't participate without me. I bring a lot of biological know-how and domain expertise on that side. They bring a lot of expertise in informatics, tooling.
Yeah, they've got expertise outside of your own expertise. Hence, they're a good team. I'm quite proud, actually.
Yeah,
one of my contributions is actually one of my ex-PhDs with Mark Coles there. So Roger Lee is up there with you.
Yeah.
I can't imagine him ever arguing, though. I can see him not listening to you.
Well, yeah, Roger worked with us for many years and incredibly productive. We don't run an organization that's about, listening to me. And, listening is one thing, taking commands that's not how this is supposed to work. Right?
Yeah. So with all those stresses, balancing it, I know is not easy. And actually, you did give me some photos at this point. So at this one, this is a Jason. This picture is brilliant. Your face on the picture itself and your hair, wow, yeah. It is all over the place, mate.
Beautiful day on
the beach
in Santorini, in Greece. Yeah, lovely day with my family, actually. My wife, kids, my sisters, my mom. Yeah, we're all there together.
Wow. And Womley, so you go to Greece with your family, your children, your mom, and you call that winding down?
Oh, absolutely. Yeah.
With all of them together. And then there's this picture is of you on where is it, Jason, this picture?
That's the Isle of Harris, the Hebrides in Scotland, and that's October in the Hebrides. So anybody knows anything about the seasons in the UK, it's getting pretty rough at that time. So that's the autumn holidays, and I had a brilliant idea to drag the family out to the Isle of Harris.
I've got to say, I'm just looking at your daughter there, propped up, leaning against you, thinking, this was not such a smart idea, Dad. Dad, you think you're clever? This isn't one of your best ideas.
We talk about it fondly at the time, and still we refer to it as the holiday of death marches. Because we walked up and down the island and across, and the kids were like, this is... I guess I'm not allowed to swear, so I'm not allowed to actually say what they said.
They look too nice to swear. I'm sure neither your son or your daughter would be swearing at that point. And you look semi-engaged.
Pass.
Yeah, he looks like he's enjoying the nature and looking down and seeing what's actually.
Yeah. Here we go, walking again. No, it was a lovely time. Harris is beautiful. It's one of the, yeah, it's my wife.
This one, Jason, I love this picture because you can give me an even bigger quiff, and now I've got a different wife. That's it's a perfect size.
Well, she'll be back in about half an hour. You can. That's in Singapore. And actually, I mean, you talk about.
I reckon I know where that is actually in Singapore as well.
It's in the Marina Bay Gardens, I think.
Yeah, just by the race circuit, isn't it? For the Formula One, it's the pit lanes are just the other side of there.
Was on an advisory board there for many years at the A-Star, one of the A-Star institutes, and would go out there once a year. And a couple of times Milky came out with me, and we had a lovely time after meeting. So I guess that's, on the travel side, I quite deliberately don't add any extra days almost ever, except if I'm with my family. So
that's cool. So they get to go out occasionally with you then?
Oh yeah.
So Elmie's never been in a good enough location to bring your family. Is that what you're saying? So I've never seen them at an Elmie meeting, for example.
No.
Oh, now you've just offended half of the people around Europe and all the places that it's taken.
I know. I'm going to get it for that one.
You've offended the US. You've offended the rest of Europe.
Oh well. Honestly, yeah. What can I say?
Jack, how do you remain motivated? Because you've had so much success. You keep moving forward. I think we'll talk next about bioimaging UK, Eurobioimaging, global bioimaging. The amount of effort and energy it must take out of you. You've got Glencoe, you've got your research group, you've got these initiatives on the go. What keeps you motivated, and how on earth do you keep the momentum going?
It's kind of hard to answer that question because I almost don't recognize I wouldn't even know how to answer that question. I
just do.
I mean, the science is so darn important. I think it's one of the privileges of being a research scientist is what you're doing is by its nature contribution to your society. It's a real privilege to have such a position. So yeah, that's enough. I don't know how to answer the question beyond that.
Yeah, I'll put words in your mouth. You mentioned earlier you've got a really good support team.
Yeah, I mean, maybe a way of answering your question. I have an amazing team. I feel duty bound to do my job for them, to deliver for them.
Yeah.
And often, if you strip it down, my job is to work with them and for us together to do important work. But my job also, going back to what we were just saying before, my job is to, market, to present the work, to show the world what we're doing, to hopefully see how our work can impact their work. My job is also to continue to raise the funds to fund the work, right? To write the grants, etc. So there's motivation for funding. You're feeding an awful lot of families. I mean, to put it very bluntly, right?
Yeah, I've just realised why you accepted this interview now. You're just going to keep the message out there, keep it going. Damn, I thought it was just a friendly thing. Say, yeah, Pete, I'll do it with you. Not at all. At least you'll tweet about it when it comes out.
Yeah, I'll do my job on Twitter for
you. So moving through, actually, I've got a couple of other bits. What is your favourite publication? It doesn't have to be that you've authored or co-authored. It doesn't have to be your stellar publications. Yeah, which one are you most fond of?
I think probably two, for two different reasons. The first is the main paper that came out of my PhD. And I think if anybody read it now, it would just, God, that's a pathetic piece of work. But, it was one of the first live imaging experiments, right? And it was, and, I remember clearly there was a huge question in the field about how chromosomes were constructed and how various proteins were acting on the on chromosomes, and there was decades of work looking at looking at chromosomes from different preparation methods, different fixation methods, and so on. And this was one of the first experiments to look at in a live organism, and the results were astounding. It was the results, the first time I got the results, so I'm sitting at a microscope at very late, 1 or 2 in the morning, and the way the protein was moving on and off the chromosomes, no one had ever predicted before, right? That anything could happen. And in fact, our cameras weren't so sensitive. And so basically there was this moment in the cell cycle where the protein I was looking at, topoisomerase II, completely diffused off of the chromosomes. What that meant is the signal was diffused below the detection limit of the camera, and basically the signal went, all I had was dark noise. And I was just sitting there thinking, what happened? How did this system break? Now I'm looking at dark noise, right? Why? How could it possibly, what could have gone wrong? And then the signal came back as the protein relocalized. And then I fell out of my chair and bruised my bum really badly. But it was a profound scientific result. So there's one.
So Jason, I'm going to ask about that first publication. That was in the days you had to write it, print it, and post it, wasn't it?
Oh yeah, I mean.
Do you actually recall? I recall my first moment. I remember going with it in the brown envelope and putting it, wishing it well as you post it through. Can you remember that moment?
Well, there's, I think, 2 copies of the printed manuscript, 2 copies of the all of the made-up figures on storyboards, etc. Right, and I think on that one, I think we probably had them photographed and submitted the photographs, and all of that is in that big brown manila envelope. Absolutely, yeah.
It's so different now. You don't remember clicking send, but putting it through that letterbox, kissing it, praying, and putting it through, saying, "Please be successful. Please like it."
I think this is 2 old men, remembering their good.
Oi, less of the old this side.
But,
cheek of it, man.
But yeah, so that one, and then I think the other one is our paper that was we published. The first paper we published on Amero, the data management system that we built over many years. That work started in 2004, 2005. The paper was published in 2012, I think, and just an enormous amount of work from a whole bunch of different people, and brought in contributions from the community. It was just a great example of what we were trying to do with OME. So.
That's 8 years of work to get to the key paper for that work.
I mean, and in person years, many times 8.
Which I think is actually a credit. You've mentioned a couple of the funders already today, BBSRC, Wellcome Trust, and so forth. I know there's been funding from other avenues. They put a lot of trust in scientists. They put a lot of trust in you. Some of these ideas are very holistic. They're very community-driven.
Yeah.
They're not, in some of these cases, they're not to solve a specific biological question, which fits kind of a bit outside their remit at some cases. But they put the faith in it. It's taken 8 years to get to the big impact paper for 2012. IDR was an incredibly fast turnaround. That was within a year or so of coming through. But I think our funders, we've got to give them credit for putting faith, because this is where the big impacts are made. And sometimes it doesn't happen overnight. You've got to keep going and have faith in your work.
Yeah, I mean, I've been very, very fortunate to have here in the UK quite forward-looking funding bodies. I don't, and I, they don't. I'm sure they don't. I know they don't do this with all of their funding. Right? They are willing to take chances. and willing to have that longer view. Yeah, and we've been a beneficiary of, I think, a great funding environment here in the UK.
And I would actually rewind back almost to the start of today, that international profile. You have to be a salesman. You have to make sure that people know and are aware that there's a need in the market. So someone going to welcome out the idea, but the community has to be ready to have that foresight. So when it goes to reviewers, they already are kind of aware that this is a need. And so it does come back, it is a salesman type person. It's international profiling, getting messages across and checking it's real and needed.
Yeah, I am a little concerned about the state of science. So, you're talking about giving talks at meetings, etc. The pace of publication now is so high that, keeping track at all and reading things deeply is super hard. It's just, speaking for myself, it's beyond the, physical capability. So, there's an awful lot of science on Twitter. There's an enormous amount of imaging on Twitter, right? So people are exchanging ideas in that medium. I think that there's a reason people are doing that, right? I also think there's a reason that, we have this proliferation of meetings and symposia, et cetera, and all of that's great. But I think it does serve a purpose in a condensed, in 2.5 or 3 days, you or I or our colleagues can sit through a very dense, packed presentation and get a sample of what's going on, right?
Well, I think that fits the bioimaging community in general is very collegiate. Of course, we compete against each other, but everyone supports and helps each other. I think that's quite exceptional across. There's 1 or 2 other technologies, but a lot of other communities are far more divided. And I think there's been several initiatives. Bioimaging UK is one initiative that's really brought the UK certainly closer together and follows across Europe into global bioimaging as well. Yeah. And you've been behind a lot of that in the UK and Europe as well. So, well, just briefly before we wrap up, it'd be good just to hear a snippet, because not everyone will have heard of Bioimaging UK, Euro Bioimaging, Global Bioimaging. So actually, salesman, I'm going to give you a couple of minutes to pitch on this.
Okay, the sales pitch. This is all about research infrastructure. And again, kind of going back to what we're talking about. These are about capabilities, about open access to those capabilities that then underpin scientific discovery and advances. One of the principles is that imaging is an absolutely key component to modern biological and biomedical science. But, Pete, and you know this as well as anyone, over the last couple of decades, the rapid development of new technologies, and critically, so, you guys at York, maintaining that capability for your, even for your local community is really hard, right? And it's basically impossible to have enough funding and enough expertise. Nominally, maybe somebody could provide the funding, but I don't think there's the expertise to deliver that technology at all sites, say in the UK or even Europe, worldwide, etc. And I think that that realization started to appear, that there was a challenge emerging there, sort of 2005, 2008, something like that. Jan Ellenberg gets, from EMBL Heidelberg, gets an awful lot of credit for leading the charge on neurobiomaging and starting to this idea of a common open access research infrastructure that would provide those capabilities to the scientific community. And the short version is a European scientist should be able to identify the technologies that he or she needs to do the experiment that they need to answer their question. They need to be able to understand what those technologies are. They need to be able to identify who has those technologies. Then through some review process, access those technologies, run the appropriate experiments, get the data, go home, do the analysis they need, publish the paper, right? And that's a democratization of those technologies, realizing that they're too expensive to put in all people's physical hands at all times, and that we don't have the staffing and expertise to deliver those technologies. And so there has to be a smarter way than just, I'll have mine and you'll have yours. And I think that smarter way idea ends up playing out at different levels, possibly at different geographical scales. So at the level of a country like the UK, the way of thinking about how you would do that. Then on the continental level, Europe, how would you do that? And even on the global level, so how do we bring up and have that kind of exchange and access at the global level?
So maybe not so dissimilar to data sharing. Yeah. This is, and actually, we're living now in a time where we've just come out of a period of austerity, supposedly. We're just going into another financial crisis, and the more cost effective we can be, the better it will be, and the more we can share. Okay, so from a UK side, obviously we have Brexit, which everyone knows about. Ultimately, science doesn't recognise borders, and it's really important to move that, because we can work far more efficiently together than we can competing against each other and duplicating efforts. I think we're going to have to do more of that to respond quicker to address scientific needs. And I think actually the latest outbreak is a perfect example of that.
Yeah, I agree. I mean, there's the fiscal aspect to this. I think we have a responsibility to our community to be as efficient and powerful as we can with the technologies that are ultimately funded by our society. So yes to that. But I also think the exchange of information and ideas is key to advancing, moving our scientific advances as quickly as possible. So yeah, I completely agree.
So something I quite like finding out about people is what car they drive. But what was your first car?
I can see where these questions are going. A VW Golf.
Gosh, you were successful early on, weren't you? Why that you didn't get a car till you were much older?
You had seen it. This was a cast off from a sort of friend who became less of a friend when I discovered how he had temporarily tweaked the engine so that it would get me home. But after that, fell apart. So.
And it was very community-minded of him, though. That's very in tune with what you're up to. And what are you driving at the moment, Jason?
That would be a VW Golf.
Tell me it's not the same one.
Definitely not. The first one. It's somewhere in a junkyard in San Francisco. I'm glad to see the last of it, but yeah, it's still Golf.
So actually, that surprises me. I thought with your passion for walking with the family, living up in near the Highlands in Scotland, you might have at least had a 4x4, or have you had that in the past?
Haven't, but cars gotten us everywhere we've needed to go. So,
I'm kind of surprised you didn't say it was an aeroplane as your current car.
Yeah.
So. Jason, you've been brilliant to talk to.
Oh, it's been great.
It's been good fun. That microscope room, that image is going to last with me for a long time. And I will see you on Zoom, no doubt.
So, can I ask you a question, Pete?
Oh, go on.
So, how many of these interviews have you done?
Done so far? We've done. This is number 4. There's another 2 already scheduled, and my list is quite long actually. I'm starting with close friends first, I think, but there's some really good ones also lined up. And
so why are you doing this? What's your motivation?
Do you know what one of the people I'm going to be talking to, and hopefully both of them, Scott Fraser inspired this idea. Elmy Dublin. Do you know, I actually hate introducing people, which is perverse considering what I'm doing here.
Yeah.
So, if you're one of the organisers, you have to up and introduce a plenaries, and I'm worried about getting their background wrong, quoting stats, and just going through their CV. And actually, in the audience, I don't find that terribly interesting.
Yeah.
So I sat down with Scott and I thought, actually, let's just talk to him. Let's find out what his interests are. Let's introduce him, Scott, not the scientist, but Scott himself. And he has such an amazing background.
Yeah.
Really entertaining. It just shows that actually, I think we always see the stellar stars in science, like yourself, like Jennifer Lippincott-Schwartz, like Tony Wilson. We see them as these people who have got a focus, they know where they're going, and that's where they get to, and they work night and day at it. Whereas actually, they're in a completely different place to where they started out. They have an amazing stories outside. They have excitement outside of work, and it's balancing that. And I think that's a great message to get to PhDs and postdocs that are thinking, I have to do this. Well, no, as you said earlier, you follow a path. You don't know where it's going, and you follow where you can deliver.
I also think, Scott is an amazing scientist. Consider him a friend. I mean, he's so much fun to be around because he's very quick and very imaginative. And so I'm sure that was a fun interview. I think one of the most important, I feel a little bit, I don't want to say intimidated, but you talk about, yes, my group and I have been successful. Jennifer Lippincott-Schwartz's group has been incredibly successful, but boy, oh boy, we've all had a lot of failures as well. Right? And I think there's, I know Scott has as well, but that's part of science and part of recognizing that, what you're doing is you're trying things and you're looking for opportunities. Some things pan out and they're great. And going back to your question about salesmen, yes, all of us will, stand up at the podium and present those stories as well as we possibly can. Part of, are we selling? Okay, maybe, but really what we're doing is exchanging ideas about our ideas about the science that we're working on, about the systems that we're interested in. And so that appears like, oh, they have been so successful, and that's true, but that's because of it, through lots of things that haven't worked out so well.
I've got a question.
Recognizing when when something is just not working, okay, it's not working, but okay, what can I learn from that, right? And actually in the OME case. Yeah, in the OME case, we had, I'll just tell, this is a very personal story, but we started down a technical path around 2001, 2002. And I had managed to get the first batch of funding for OME's work late 2002 from the Wellcome Trust. Talk about taking a gamble. By about we were working down this path, but we could start seeing the limitations of what we were doing. And by about 2004, and I was going to have to get the next round of funding around about 2005, okay? And I received an email from a guy at Stanford who was really trying to use the work that we were doing. Was picking up the software and working it through. And he said, he wrote in this email, he said, I'm really amazed. What you guys are doing is so incredible. It's really impressive what you've been able to achieve. I have to say, it took me 6 months of reading all the documentation code to actually understand what you guys have done. But now that I have, I think I see what's going on. And at that point, I realized, we were sunk, right? And the words I used at the time were much more profane. right? So that was we were failing, and so okay, we're not delivering for our community now, and that's a failure, especially given the what had been invested. So what are we going to do about that, right? How do we figure out how to move forward, right? Out of that conversation, out of the recognition that we had failed, was born the ideas around Amero, discussions with Josh Moore, Chris Allen, etc., and then an idea of a new idea, which then we start taking forward. So I think I don't know if that's probably more, it's probably worth remembering that those successes come from our hard won.
Yeah, and I think there's always regrets, things you've had to leave behind that you wish you could have solved, but maybe technology or something else just wasn't in place at the time, and doesn't mean it's not worth revisiting 10 years later.
Yeah, exactly.
Right? Things move on. Things that weren't possible or didn't seem right, things do change, and that's a key thing, is never to say, I've tried that, done that, didn't work. I tried that, done that, didn't work 10 years ago, but actually it might do now.
Yeah. We're actually at such a moment in OME. We're looking at some new technologies that recast a lot of those early ideas, but now with a completely new ways of implementation, which make it maybe possible to do some of these things. So, yeah.
Jason, I know that one of the ways you relax is doing yoga after giving you a good workout for the last hour or so. Yes. I'll let you get back to your yoga mat. And very different to cycling, may I point out?
Yes, but going head first, very fast down a hill, has a certain set of risks. At some point, this is safer.
I'm not sure going head first onto a mat doing yoga, I think, has its equal danger risks to it.
Anyway, thank you, Pete.
Yeah, Jason, thanks very much. Thank you.
All right, talk to you later.
Thank you for listening to The Microscopists, a bite-sized bio podcast sponsored by Zeiss Microscopy. To view all audio and video recordings from this series, please visit bitesizebio.com/the-microscopists.